All right, just continuing a review of chapter 13 here. A couple more sine, cos, tan questions for you. So my recommendation on this one is draw a picture first. So again, I'm going to ask you pause the video, try it before continuing. Okay, so we got this trail that's going uphill like this, okay? And it is 5 miles. So along this little side of it, we can label 5 miles. Okay, so and then the ascent is 3,000 feet, right? So we actually probably have to convert, right? So here's what my right triangle is going to look like. If I can get this to work right here. Sorry, I'm struggling a little bit. Draw it straight down. That's the 3,000 feet ascent. That means how much it goes up. And then, sorry, my picture's all wonky now, but hopefully we get the idea. So it looks something like that. And then on this side, we have, again, the 3,000 feet. And so probably you could turn that into miles, but I'm actually turn the miles into feet. So I'm just going to take 5 times that 5,280. Yeah. Yeah, both are units in feet. And so our angle of ascent is going to be that angle right there. Okay, so we're going to use an inverse sine cos tan to find that angle. So at first I got to figure out which one is it, sine cos tan. And it looks like we have op and hypotenuse, the long side, the side across, the long side. So we could say that the sine, right, op and hypotenuse is sine. So we could say the sine of our angle is opposite 3,000 over hypotenuse 26,400. So the angle then, to get the angle, we would do sine minus 1 of that ratio. Okay, and that will get you the measure of the angle. Okay, so we're going up on average about 6.5 degrees. That's what we get. So kind of a slow ascent, but that's normally how you do a trail. You wouldn't want to make it super steep. Otherwise, it'd be too hard for people to get up. Okay, last one. Find the height of the tree. So we've got this dude here that's 5 feet tall, and he's measuring up to the top of the tree, right? And so the picture's actually given to us here, but we just got to find the height of the tree. So pause the video and see if you can figure this out. Okay, so what we're going to do first again is figure out, is it a sine, cos, or tan question. So we have x here, and that would be, from the angle's perspective, that would be the opposite leg. And then this 42 is another leg, and it's just the adjacent one because it's right next to the angle. Okay, so that means it's going to be a tan, and op adjacent is tan. So our setup would be the tan for 43 degrees is equal to op over adjacent 42. Okay, and now we've just got to solve that. Okay, so I normally turn tan 43 into a decimal using my calculator, so I'm just going to type that in, and I get about 0.933 to 1. So they're almost equal, it looks like. Op and adjacent are pretty close to equal. It's just 0.933 to 1. And then our ratio is x to 42. And now we've got to solve that. Sorry, my thing is messing up here. Solve it for x. So we're going to do 1 times x equals 42 times that. So I have 42 times 0.933. And so x is whatever those two things are multiplied. So that's 39.2 feet. So I'm going to label that in my picture because that's actually not my answer, right? That's just this yellow piece here. We've also got to account for the extra 5 feet because our triangle started 5 feet off the ground. So our full height would be 39.2 plus 5, so that would be 44.2 feet tall. And you can actually imagine measuring a tree this way. Definitely you could measure, a certain distance away. The hard part is, how do you measure to the top of the tree? You need like some sort of protractor or special device to do that. But otherwise, you could use this strategy to measure the height of an actual tree. So that's it for the review. Thank you for watching.